All right, let's get right into it. For a century, the world ran on oil. But today, there's a new resource that's just as valuable, just as contested, and it is sparking the next global power struggle. We're talking, of course, about data. This is the story of how we went from a data boom to a data war.
First things first, we need to wrap our heads around the sheer, mind-boggling scale of the data explosion we're all living through. I mean, the numbers are just staggering, and they're growing at a pace that's honestly hard to even imagine.
By 2025, humanity is expected to be generating about 181 zettabytes of data. So what on earth is a zettabyte? Well, it's a trillion gigabytes. So we're talking 181 times trillion gigabytes. It's a number so huge, it's pretty much impossible to really grasp.
Now, look at this chart. What's so wild is the trajectory. This isn't some gentle slope, it's a vertical rocket launch. Data is no longer just a byproduct of what we do. It's become the main thing we produce. But, you see that red line? All this data comes with a massive and skyrocketing cost to just manage it all.
So that brings up a really important question, right? We're swimming in all this data, and we're paying a fortune just to keep it afloat. How do we actually turn this overwhelming flood from being a huge cost into a truly valuable asset?
Well, the secret sauce, as you can see here, is reuse. See, data is often treated like exhaust fumes from a car. You just use it once and it's gone. But the real magic happens inside that little infinity loop. When you continuously process data, share it, analyze it, it stops being exhaust. It becomes this incredible, sustainable fuel that actually gets more valuable the more you use it.
And of course, this super valuable data is what's powering the most important technology of our time, artificial intelligence. But there is a huge, huge problem just around the corner that the entire tech industry is scrambling to solve. You know, for years, making AI better has followed a surprisingly simple recipe. It's called the scaling law. Basically, you just feed the models more high-quality data, throw more computing power at them, and voila, they get smarter. It's been this really reliable, brute force way to make progress. But we are about to slam into a wall. Just look at this chart. The blue line, that's all the high-quality human text on the entire internet. The red line is the insane appetite of new AI models. And right around 2028, they cross. We are literally running out of the fuel that powers AI. So, if we're running out of data, we can just scrape from the internet. Where is all the new data going to come from? Well, the answers start to reveal this invisible and very human side of the whole data economy. So, you've got two things happening at once. On one side, you have these massive legal fights, with companies like the New York Times suing AI labs over using their copyrighted work. And on the other side, you have the hidden labor. Behind all the magic of AI, there's this huge global workforce of human labelers. They're like the new refineries of the data age, who are manually creating and cleaning up data sets, often for pay. In this high-stakes race for data, it's not just a battle between companies. It's becoming a full-blown geopolitical fight, and it's fracturing the globe in ways we're only just now starting to see. It all starts with the physical stuff, the actual servers. The US is home to the vast majority of the world's data centers, especially from the big guys like Amazon, Microsoft, and Google. This physical dominance creates a kind of infrastructure gravity, where the world's data is naturally pulled towards it, cementing America's digital power. But other countries are starting to push back hard. They're realizing that if their data and cloud services are foreign, their AI will be foreign too. So they're building digital borders. Think legal walls like GDPR in Europe and the Great Firewall in China, all to control data inside their own territory. The whole conversation has shifted from being about privacy to being about power. And this visual illustrates the result perfectly. We're not living on a single open internet anymore. We're living in what people call a splinternet, a world that's breaking apart into competing data zones, each with its own rules, its own values, and its own alliances. So you basically have three major blocks emerging from this. There's the US-led Open Coalition, pushing for the free flow of data, at least between friendly countries. Then you have the closed bloc, centered on China, which is all about state control and data sovereignty. And then there's the EU, which is trying to carve out a third way, focused on strategic autonomy and European standards. Now, here's the really crucial part to understand. These different geopolitical blocs, they're not just arguing about tech standards or trade deals. They are built on fundamentally different ideas about what data is and who should get to control it. So, what is data? Is it like oil?
A private asset you can just pump out of the ground and sell for profit? That's pretty much the US model. Or is it more like a public resource, something the state should manage for the good of the nation? That's closer to the China model. Or is it something totally different, like public infrastructure, a shared good, like roads or bridges, that should benefit everyone? That's the vision the EU is chasing.
And ultimately, every country, every company, and every one of us is caught in what this slide calls the policy trilemma. And it's basically an impossible balancing act. You can have national security, or global innovation, or individual rights. But trying to get all three at the same time, it's incredibly difficult. You always have to make trade-offs.
Which leaves us with one last, really tough question to think about as we try to figure out this new world order. In a world that's being rebuilt on a foundation of data, which corner of that triangle do we sacrifice for the others? Our privacy, our security, or our progress? There really are no easy answers.